Hello all. We are on our last lesson for our volume chapter, which I feel like we just whizzed through. I think there's only anywho, doesn't matter. But yes, we are on our last lesson for volume, and it is very similar to the last lesson we did on area, because you're going to be comparing similar and congruent figures. Like I said, you're going to see a lot of similarities to the lesson we did about probably 2 weeks ago. There's just a little something different, obviously, because it's volume and not area. But this shouldn't go so bad if you had a decent grasp on what we did with the similar areas lesson. Just to recap things that I know you probably know this, but similar solids are the exact same shape, but are not the same size. So like one's bigger and one's small, right? It's just like enlarged or shrunk. That's all it is. Whereas congruent solids are the exact same shape and the exact same size. Their scale factor would be 1 to 1 because everything about it is the same. It's like they're identical twins. Okay? Because this is kind of important. Well, we'll get there. We'll get there. I just get ahead of myself sometimes. Let's just take a second here and look at this. So what would our scale factors here be? So remember, your scale factor is when you pick sides that correspond to each other or match and then reduce. So I always like putting the small one on top. So this 4 corresponds to this 8, right? So I'm going to have 4 over 8. And now I reduce. You always want to reduce your scale factor, or really in general, because it makes your life much, much easier when you calculate. But remember, we get 1/2. Now, the ratios of your areas are surface areas. So do you guys remember what we did? So if you're at your scale factor, remember we said this is like A to B. How do we get to A squared to B squared? What do we have to do to these guys to make it A squared to B squared? Yeah, you said it. We square it. So I'm going to have 1 squared is just 1, and 2 squared is 4. So this would be the ratio of our areas. So really, this was the lesson we did a couple weeks ago. Okay? Now, today, we're going to do ratio of our volumes. Okay? So volume, remember, is just base area times height. So if I wanted to find the volume of the little guy, it'd be 4 times 4 times 4 times 4, which would be 64. And if I wanted to find the volume of this big guy, it'd be 8 times 8 times 8. Oops. Which is 512. I don't know if that's helpful or not. Is that helpful? Can we reduce it? Will it make our life easier if we can reduce it? And sure enough, it does reduce to 1 over 8. So now, the question I ask you is, there's something that we can do to our scale factor, 1/2, to get to 1/8, the ratio of our volumes. How can I go from here and jump to here? Well, let's just think about this. Your scale factor is linear, so you don't do anything to your units. Your area unit is squared, hence why we squared it. And what is your unit of volume? It's like centimeters or inches cubed. So if I cube my A over B, I'm going to get the ratio of our volume. So A cubed to B cubed. And a way we can check that is right here. What is 1 cubed? 1 times 1 times 1 is just 1. And 2 cubed, 2 times 2 times 2, does indeed give me 1/8. This is very confusing. I'm sorry, I don't know why I decided to do it this way, but sometimes, I don't know, I just don't think. But if you were to take anything away, let's just go down here and this is what I want you to write down. So your scale factor is A to B. your ratio of areas or surface areas, depending on what you're given, would be a squared to b squared. And then the ratio of volumes is a cubed to b cubed. Okay? This is going to be your little roadmap. We'll write it all out together when we get there. Don't freak out. We'll be just fine, I promise, okay? We got this. Okay. Let's see what we have next. We are asked, determine if the solids are similar, congruent, or neither. If the solids are similar or congruent, state the scale factor. Okay, so for them to be similar, remember they have to have the same scale factor, so we just have to match. So let's start with 8. What does 8 match on this pyramid here? Well, it matches 12. So now our scale factor, we just reduce corresponding parts. So what goes into 8 and 12? Well, 4 does, so I'm going to get 2/3. Okay, now we have to check our other dimension on here. So my height, 4, corresponds to this height of 6. So 4 over 6. And yes, this does indeed also reduce to 2/3. Since they reduce to the same thing, they are similar. And our scale factor is 2/3. Let's try another one, just like that. Determine if the solids are similar, congruent, or neither. If the solids are similar or congruent, state the scale factor. Incredible, we got this. Okay, again, we just pick things that match and we go with it. So let's see here. I'm going to start with this guy on the right because it's the smaller one, and I just like putting the smaller number on top because that's just how my brain works. So let's just start with our height. So 1.5 corresponds to 2.5. Okay, just a fun fact. If you're given like decimals in your problem and you're supposed to write it as a scale factor, do yourself a favor and just divide it out and get a decimal. It's not worth your time trying to simplify it in your head. But if we divide those out, because that's all that you're really doing is just dividing, we get 0.6. So 0.6. Okay, now let's check 3.4 corresponds to 6.2. Let's see here. So again, like you could probably try to figure out what goes into 3.4 and 6.2, but it's just easier to check it on your calculator first because that is just a much more efficient thing to do. So we get 0.54. 0.54. So right now we're done with this problem because if we notice, did I get the exact same thing here? Am I reducing to the same thing? No, we're not. They're not the same. So they are neither. They're not similar or congruent. They're neither. Okay, that was fun. Those are good problems. Okay, super. Let's see what is next. Okay, here we go. It says we have two similar cones that have radii of 9 inches and 12 inches. What is the ratio of the volume of the smaller cone to the volume of the larger cone? Okay, how about we draw a picture? Because sometimes pictures help us. So I'm going to draw 2 cones, or attempt to. There's one cone. We'll make that one my smaller one. So that one has a radius of 9. And here is my larger cone, which has a radius of 12. Okay, give myself some space here. So now our job is to figure out what is the ratio of their volumes. Okay, so let's think about this. This was our little roadmap. A to B, A squared to B squared, A cubed to B cubed. So on our little chart here, Scale factor, ratio of areas, and ratio of volumes. Where are we at? Like, what do I know? So let's just start here. Can I write their scale factor? Do I have two measurements on here that match? Yeah, we sure do. So let's start there. Let's start with our scale factor. So our scale factor would be 9 over 12. Again, save yourself a headache in a little bit and reduce, okay? So I'm reducing because 3 goes into both of these, so it would be 3/4. So this is my scale factor, 3/4. And now we want to find what is the ratio of the volume. So we can say, see ya, we can go right past the ratio of our areas and jump right to the ratio of our volumes. Because look, all I have to do to my scale factor is cube it. So from here, go to the ratio of our volumes. So 3 squared, cubed, over 4 cubed. So 3 times 3 times 3 gives me 27. 4 times 4 times 4 is 64. And that is it. We did it. So the hardest thing, I think, in this lesson will be deciphering what you're given to know at what place you're at on our little roadmap, and then to figure out which part they want you to find. That's the hard part, because you guys can do this. You guys can cube a number and you guys can write a scale factor. You know, that's not the hard part. The hard part is figuring out what the question's asking you, okay? Let's try this next problem here. Okay, let's see. It says the figures are similar. Find the height. Okay, so again, we have options. We have scale factor, ratio of areas, and ratio of our volumes. So we are looking. So scale factor. Do I have two measurements on my cylinders that I know both of? Well, here's a 10, and there's an H, but do I know what H is? No. So we can't start here. Do we know the areas of both of these cylinders? Not currently, but we probably could figure it out later on. But now if we look, do I have the volume of both cylinders? Yeah, look, they say the volume is 270 pi. Volume, 640 pi. So this, today, is where we are starting. So let's write that down, ratio of volumes. Okay, again, I'm putting the small guy on top because that's how my brain works. So I'm going to write 270 pi over 640 pi. Okay, and now we are asked to find the height. So in order to find the height, we're going to have to get to our scale factor. So at some point, we need to get to our scale factor from here. Let's first reduce this. Let's see here. Well, the good thing is our pi's cancel out, and those zeros say see ya. And now from here, does 27 and 64, does that simplify anymore? It doesn't. So our ratio of our volumes is 27 over 64. Okay, I should have wrote this down quick, but I'm doing it now. It's fine. It's fine. We're all fine. Okay, so this is where we're at. We're at a cubed over b cubed, and we want to get to just a over b. So how do I undo something cubed to get just a? Well, you take the cubed root. So remember last time we took the square root? This time we're going to take the cubed root. And if you're like, well, what is she talking about? We've never talked about that. Well, we probably did it like once in Algebra 1, and then your teacher's like, you'll learn more about this next year. And that's what we say every year, right? So let's just see if we can figure this out. So if you have a calculator and you don't know what the cubed root of 27 is, this is what you do. You're going to hit 3, because it's the cubed root, and then you're going to hit second, and then I'm going to move this up just a tish. On my calculator, it's the little up arrow, so it has like the x with the square root, so it looks like that. And then you hit 27. And obviously it's 3. We just did a problem that had the same number, but if you didn't know how to use your calculator, Now is a great time to learn. Now let's try it again with 64. So again, since it's the cubed root, you're going to hit 3. And then you're going to hit second. And then the little up arrow, because we want the square root with the x right there. Perfect. And now we type in our number, 64, and we get 4. So now our scale factor is is 3/4, but we still haven't answered the question of find the height. So now if you remember from that other lesson, this is when we can write our proportion. So I can write 3/4 is equal to h, because the 3 corresponds to the small guy, h over 10. And now we just cross multiply. So I'm going to have 4h equals 30. Divide by 4, and h equals 7.5. What is our unit? Inches. So hopefully this little flow map should look familiar, right? The only thing different today that we're adding is instead of just having these two, we're adding the volume. But otherwise, you guys, it's the exact same lesson. Literally the same. Okay, let's try another one. Now we have some softball and baseball players in our classes, so this is exciting. It says the softballs below are similar spheres. If the radius of the larger softball is 1.9 inches, find the radius of the smaller softball. So let's just draw, or I'm going to draw in my pictures because I just love a good visual. So the radius of the larger one is 1.9. And we are asked to find the radius of the smaller one. So what's a question mark? We don't know what it is. So again, out of our scale factor, ratio of areas, and ratio of volumes, we got to figure out where we're at right now. What do we know both of? Well, we clearly can't find the scale factor because I'm missing my radius, so that doesn't help. And if I don't have my radius, we definitely can't find the areas of both of these. However, folks, look, we are given the volumes of both. So let's start with the ratio of our volumes. I'm going to put my small one on top. So 4.06 pi over 9.15 pi. Again, reduce, reduce, reduce. Our pi's say goodbye. And now, yeah, we have decimals. Just leave it like this, you guys, that we're not going to monkey with it. Just leave it as 4.06 over 9.15. Oops, now we can't see. Love that. Love when that happens. Okay. There. Okay, so we are at the ratio of our volumes, and I eventually want to find the radius. So what's going to help me? My ratio of my areas or the scale factor? Scale factor. Okay, good job. So now, how do I get from the ratio of my volumes to my scale factor? How do I get rid of the 3, the power of 3? Take the cubed root. Good job. Again, I'm going to show you quick on your calculator. You're going to hit 3 because it's the cubed root. And then you're going to hit second, the up arrow, so it has that little x in front of the square root. And then you just type her in. So I get about we'll go to 2 decimal places. So that gives you 1.6. And now if we do it for the bottom one, again, 3, second, square root, 9.15, 2.09. Okay, so now we have our scale factor. And then from here, we want to find this missing radius. So I'm hoping you're thinking, proportion. I can write a proportion to find it. You can. So 1.6 over 2.09. Okay, 1.6 corresponds to the smaller one, which is R. 2.09 corresponds to the big one, which is 1.9. And now we just cross multiply. .04 divided by 2.09. R equals approximately 1 point, to go 2 decimal places, 45 inches. I should know, I don't know, you guys, I don't know if that's small, big for softball. To me, I think it's, see, maybe for a radius, I don't know. Not sure, but that's what we get. I know this is confusing. Just try, write your little flow map. Come to the Zoom. We just do the homework. So if you're totally lost, show up to the Zoom. We do the homework the entire time, and then you walk out with no homework. So show up to the Zoom if you need help. If not, shoot me an email, and I would just love to help you, or just chit chat. As always, I hope you guys are doing well and safe. I miss you. Be united. Live the tradition. Onward Central Kindness Week. Okay, toodaloo. Talk soon.